Starting the recording. All right, so today we are looking at analyzing graphs, okay? So you can see right here all of the things that we are going to be doing. So yesterday I didn't go through some of the graphs because I told you I wanted to spend more time and wanted to make sure that you're going to do this. So as you look at this, as we go through it, there's really 4 graphs that you're going to find all of these things for. How the notes are going to work is I'm going to do 2 of them with you. We will go all the way through it and make sure you see it, see each set, everything that we're trying to do. And then after that, your practice / whatever you don't finish will be your homework, is to do the other 2 sets for this. Okay? So we've got that going on. All right, now, here are the things that we are going to look at, and we'll go through them one at a time. Domain and range, which is something that we're seeing. So domain and range, increasing and decreasing, max and min, x and y intercepts, and in behavior. We are going to get all of this by looking at graphs. Okay, so we're going to go through it. I'll talk to you about how we do it. We'll talk about what each one is and go from there. Okay, so the first thing we talk about is going to be really a review. It is going to be the domain and the range. Okay, we talked about this yesterday. The domain is the set of all x values of the graph. How you figure this out is you are going to look from the left to the right for the domain. So we are looking from side to side. Okay, and we'll talk to you about what that looks like. For the range, that is the set of y values. To figure this out, you are going to look from low to high or from bottom to top. Okay? Those are going to be the things we look at. Those are going to be the things that we do. All right? So domain and range, we talked about what they are, all of that jazz. Okay? All right. So looking here, we're going to start by finding the domain and the range, and we're going to look at graphs. Okay? Now, here's something that I want to tell you. Unless it is denoted with a dot, you are to assume that everything has arrows on the end of it. So what I mean is, as you look at this graph, there's an arrow here and an arrow here. There's an arrow here and there's an arrow here. You were to always think that there are arrows. The reason that is that means then it will continue on forever. Everybody understand what I'm saying to you? Okay? All right. So let's look at this first example over here to the left. We've got these things going, and they're asking us to find the domain and the range. Well, the side note that we have to remember is that the domain is when we want to think side to side, and the range is when we want to think up and down. Everybody with me? Okay? Well, here's what you need to know as you look at the domain. What are the ends doing? As you look at this graph, if you were to think about it, these things are going, and will they ever stop? No. If you pick this center point right here, and you just kept going and going and going and going, those have arrows at the end of the line. It's going to continue on forever. So there is never an x value that your answer could not be. Are you with me? So when that happens, you say your domain is... Anybody? Huh? What? No, it's not -4. We literally said it's here, and it's going to continue on going forever and ever and ever and ever. Your domain is going to be from negative infinity to positive infinity. Okay? So, what you do is you say, okay, while I'm looking at this, my domain deals with which letter? X. Your domain, you've got to write an interval for it. It is from negative infinity, which is less than or equal to x, which is less than or equal to positive infinity. That's because it never stops. It continues on forever and ever. Every number is possible to get your domain. Okay? All right? Now, when you look at your range we talked about goes what? Up and down. Well, if you started right here again, are you ever going to find a point where the numbers stop or don't touch? No, because of the arrows, it's going to continue on forever and ever and ever. Okay? That would be set up as what? Well, it's going to be negative infinity is less than or equal to y, which is less than or equal to positive infinity. Are y'all with me? Now, I've shown you this notation. Can I make this easier on us all? If it is one of these where it's going to continue on forever and ever and ever and not touch any of the stuff, and not stop. Instead of writing it in this interval notation, I'm going to give you a phrase you can use. Are you ready? The phrase is going to be all real numbers. So since these have negative infinity and positive infinity on them, instead of saying, hey, it's from negative infinity to positive infinity, I'm going to allow you to just use the phrase all real numbers. Because that tells me that I could choose any number in the world that I want to, and that will give me what I need. Are y'all okay with that? Okay. All right. Now, let's look at this next example that is right next to it for domain and range. Okay? Same idea here. Okay? We want to first look at this and say, okay, our domain goes from side to side, right? Well, here's what I need you to notice. If we started here and here on this graph, okay, what are these two things going to do? Will they keep going forever and ever and ever? Yeah, they will, going side to side, because that arrow means this will go this way forever, and that's going up at an angle that will go on forever and ever and ever. So is there an x value that this graph does not touch? No, there is not. So that means you could use the phrase of all real numbers. Are y'all okay? All right. Now, the range here is different because the range deals with what? Going up and down. Can somebody tell me what the issue is? Does this keep going down? Right here, this little section right here. No, it starts to flatten out. I know that because the line is horizontal. Does this continue going up on this end? Yeah. But the issue is it ever going to get smaller than this number 4? No, because that is where it flattens out. So we have to write an inequality for our range. Our range is going to be every y value that is bigger than 4. Do you hear the words that are coming out of my mouth? So you have to come down here and put that inequality into perspective. So remember, over here we had a starting point, the letter, and then the point where it goes to. Well, the smallest number needs to go over here. What's the smallest number this graph is? Hopefully you say 4. Y'all are going to be in for a rude awakening. It's going to be 4. Okay? And that is going to be less than y, which will have to be less than or equal to positive infinity. How you get all of that? This starts to flatten out at 4. And even though it looks like it touches 4, because it gets horizontal, it'll never get to 4. That's why it's not equal to 4. But over here, it continues up and goes on forever. So that's why it goes to positive infinity. All right, so there is that information in domain and range. So as you can see on this next slide, I'm going to leave these 2 examples for you to work. I'm going to let you work them. We'll go over them tomorrow. Okay? Same with these next 4 examples for you to work. So the next thing we're going to go to is how you decide about increasing and decreasing. Okay? Increasing and decreasing intervals are found by looking at the graph from left to right. The graph is increasing if it is rising. The graph is decreasing if it is falling. The main thing that I want to highlight here is it talks about by looking at the graph from left to right. That means that we will only be concerned with the x values. So what you are going to do here is you are going to look at the x values and decide what the graph is doing from the left to the right. Okay? Now, how I decide that is by doing this one thing. Okay? So I'm going to show you. Now remember, we are to assume that there are arrows at the ends of both of these. Okay? Here is how I like to think about the graph. You've got to think about if you were trying to run on that graph. So what I do is I have a little guy that I call Little Muchacho that helps me out. There's Little Muchacho. He's got an M for hair. That's why I call him Muchacho. Okay? Little Muchacho loves to run graphs. If he was to run, and he always starts on the left, if he were to run this graph, which direction is he going? Up. Well, since it is going up, that means the graph is increasing. So, looking at this from left to right, he is increasing. Is there ever a spot where he decreases? No. So guess what? This is an example where you would say, when they ask you if it is increasing, you would say always. And then when it is decreasing, you would say never. Okay? Now, I'm going to do a different example for the second one because this next one is very similar. Okay? Because even though it starts flat, as he runs to the right, it's always going to be going up. Let's look at this slide, and we're going to look at the first example. Okay? Remember, we always work left to right when talking about increasing and decreasing. Okay? So, Little Muchacho is going to help us out. Here's what I need you to notice. As he starts on the left right there, which direction is he going? Down. He's going to go down and down and down until he reaches a point. What is that point he reaches? Nope. Okay. What did I say? You're right. You're just not perfect yet. I said when we look at increasing and decreasing, we only look at x values. So what x value does it get to where he turns? -3. Perfect. That's going to help us out. And then once Little Muchacho gets to -3, which direction does he start going? Up. Here is how it is going to work. Little Muchacho is going to be decreasing when x is what then -3? Well, to the left, x would have to be smaller. Okay? So, when we look at decreasing down here in the bottom, we would say the graph decreases when x is less than -3. However, when x is greater than -3, what is the graph doing? It's going up, which means it is increasing. So all you've got to do is switch the inequality to be able to write that out. Okay? I don't expect this to be perfect, but you're going to try these and we'll go over more of them tomorrow. Okay? All right. So, I'm going to leave the other ones for you to look at. Okay? Now, the next thing we got to look at are maximum versus minimum. Okay? And a lot of this is going to make sense. The highest point is what we call a maximum. The lowest point is what we call a minimum. Okay? Now, think about this logically. If we're talking about highest and lowest, which coordinate or which axis do you think we're going to look at? The X one that goes side to side or the Y one that goes up and down? The Y that goes up and down. That is 100% correct. So it says right here, if the range is all real numbers, then your graph does not have a max or min. So guess what you would say for that? None. Okay? And then just like I told you right here, the max and the min align with the y-axis. Typically, you only use the y-coordinate. So when you're talking about max or min, the y value is what is going to help you. Okay? So let's flip over here. Let's look at these two examples. Okay? You are looking here, is there a max or a min on both of these two examples? Okay? Well, here's what I want you to look at if we're looking at the first example. Is there a point where the graph is going to stop to make it the highest point or the lowest point? No. Since that is the case, guess what? Is there a maximum value? Nope. So you would say none. Is there a minimum value? Nope. You would say none. Okay. I'm going to do two more of these for you because these are a little bit quicker. So I'll do this one and I'll do the next one. All right. Looking at this example, is there a maximum or a minimum value? Huh? Yeah, there is going to be. Here's why. If you look at this graph going up and down, well, as you go up, it's never going to stop. But as you go down, it starts to level out at what number? 4. So we know we're going to either have a max at 4 or a minimum at 4. Okay? Yeah, it's going to be a minimum. So you would say you have a minimum at 4. Is there a maximum? No. Here's the deal. If you have a minimum, you're not going to have a maximum. Yeah, you just mark it out. How it'll be written typically on the stuff I give you is like this. It'll say max/min here. And you'll have to circle. So like this one, you'd say, hey, there's a minimum at 4. That's how it'll be worked out. Okay? All right. One more together that's a little bit clearer and easier to see. Look at this first example on the next slide. As you look at it, you have to decide, is there a minimum or a maximum value? Yeah, there is a minimum. So that means we don't need to worry about the maximum. And the minimum is at that lowest point. Well, where's that lowest point? No. Listen, thank you. It's at 4. We just talked about it. Max or min goes with your y-axis. Increasing, decreasing is x. Max and min is y. So it's a minimum at what number? 4. All right. So good. So there's some practice with some of those. Okay. Next one is the x and y intercept. These are, in my opinion, relatively easy to see, okay, they're relatively easy to see on a graph because an x-intercept is where it crosses the x-axis. The y-intercept is where it crosses the y-axis. So all you got to do is go and look and find points where that happens. Okay? Looking at our two examples here. Okay? On the first example, is there a point where it crosses the x-axis? Huh? I think so too. I think it crosses right there. Well, guess what? Where it says x-intercept, I just got to write that number. Now, that number is between -2 and -3. So, you just have to make an educated guess. I would say it's probably -2.5. Because to me, that looks like it's in the middle. Then, to find the y-intercept, I do the same thing on the graph, but I look at the y-axis. Where does it cross the y-axis at? Up there at 5. So the y-intercept would be 5. Questions? Anybody? All right. Now, let's come down here and look at the one next to it. Does this graph next to it ever cross the x-axis? No, it doesn't. You can actually see, we talked about it. It flattens out at 4. It never gets down there. Well, what do you say when it doesn't happen? You just simply say none. If it never crosses the x-axis, then there's not one. Now, for the y-axis, does this cross the y-axis? Yeah. Again, it just happened to be this. It's not always this number, but what number was it? 5. Y'all okay with that? Do you want to see where? Yes or no? You do? Okay. I'm going to do the second example on the next one. Okay? Here is why. When I look at this, what do you notice on the x-intercept? How many times does it cross the x-axis? Twice. So guess what? You're going to have two answers. It crosses there, and it crosses there. What are those numbers? So it would be 0 and 4. Does it cross the y-axis? This is a trick question. Yes, it does. What number? 0. It crosses at the same point as that x. So the y-intercept is 0. Here's a hint for you. If you ever get an x or a y-intercept of 0, then it's true for the other. So 0 has to show up in both the x and the y-intercept. That's a little trick that some people don't quite know. Okay? Now, the last thing that we are going to look at is end behavior. Okay? And it is as simple as this. What do the ends of the graph do? It is that simple. What is happening at the end? There are two ends to your graph. There is a left end, there is a right end. And you simply have to say whether it rises or it falls. Okay? So, watch how this is going to happen. If we look at these examples, okay, we've just got to talk about what it does. Okay? On the left of the first one, that's where it gets smaller at. What is the graph doing? It's falling. It goes down. So all you got to say is that it falls. What is the graph doing on the right? Increasing. So you just say rises. I would take decreasing and increasing as well, but I'm trying to use different verbs so that you can keep it separated. Okay? Falls, rises. Okay? Now, I want to look at the next one because it's a little bit different. Okay? Looking at it, on the left-hand side, what is it doing? Huh? On the left. It's going left. It's starting to flatten. So is it rising or is it falling? Neither. Guess what? You don't have to answer it. If it's starting to flatten, okay, you could say flatten if you want to. I'm not going to take points off for that. But really, you just don't have to answer it. Now, on the right, what is it doing? It is rising. So it rises on the right. I want to do one more with you. Okay? Third one on this next one. Okay? Now, this one is just different. It's not really hard. You just need to know that you can get this answer and everything is okay. What is happening on the left? No, look at the arrows. It is rising. It is going up. In behavior, you literally look at the ends. So in this case, both ends are doing what? Rising. So on the left it is rising. On the right it is rising. It is that simple. Now, that was a lot of information thrown at you, okay? What I'm going to do is give you time to work on the rest of these examples. If you've got a question, ask it. Tomorrow, we're not doing anything new. We're just going to look at these examples and see if you have questions. Now, if you don't have any questions, I do have a worksheet to hand you that you're going to work on. But if we end up spending the whole class working on these questions that you have, then that worksheet will just bump over to Friday. Y'all with me? All right. So I'm going to let y'all get started. Ready, set. Let's look at